Hello Bio100. So I am creating this video specifically for you all in response to some of the questions that you said you still had after going through this week 7 module. So I have put together some slides to answer those questions that you still have or to address things you wanted to see additional information for. So one of the things that several of you said you were still a little bit confused about was differentiating the where versus the what when we're looking at a results narrative. So I pulled, well, first of all, I'll just give a brief explanation again of how I think about these two things being different. I color-coded them, the where in red, the what in blue. So the where is telling you where within the paper, in what figure or in what table is this data that you're talking about actually shown. So the where is indicating either at the beginning or the end of the sentence, either one, which figure or which table you're referring to with your data. And a figure number isn't required for every sentence in the results section. So for example, if you have the first sentence references a figure and the next sentence refers to that same figure, you don't have to put the figure number in both of those sentences back to back. You could just put it in the first one. So that's the where. And then the what is that figure telling you? What is the takeaway that the data is indicating? And where it can get kind of tricky, and maybe this is where some of you are confused, you can often see one sentence that addresses both of these criteria. So a sentence in a results section does not have to be one or the other, but sometimes you can actually have both components contained within a single sentence. And so here's an example of that. Let me move my head so it's out of the way. So this is an example from that results excerpt that we were using for our lecture part of the module this week. And these sentences say, during winters 2014 to 15 and 15 to 16, we observed warmer temperatures than previous years, table 2. So this first sentence actually addresses both criteria, the where and the what. So in red here at the end, we have the where. It's telling us this data we're talking about is found in table 2. And it's also giving us some of the what. It's saying we saw warmer temperatures than previous years in these years indicated. So that's what the data is telling us. The second sentence here is also giving us even more specifics on the data, telling us more what information. So here we're saying, additionally, these 2 years showed the highest annual average temperatures. So in that first sentence, we're actually addressing both criteria. And in the second sentence, because we don't have any figure or table explicitly referenced, we don't have a where component in the second sentence, but we do have a what component. So here's an additional example. This is pulled from one of my research papers from grad school. So this sentence says the largest difference between northern and southern populations occurred at 39 degrees C. Just for some background, this paper is looking at if you take snails from northern or southern California and you expose them to warm temperatures, do they survive or not? What are their survival rates? So that's what this study is about. And the second sentence says, following this heat stress, that's high temperatures, the southern population showed 90% survival, while the northern population showed only 61% survival. So I'll give you some time first on your own. Think about what, where, and what for these particular excerpt. What criteria do these sentences address? Where and what, or just what, and where would you find it within there? I'll give you some time to think about that on your own first. Okay, if you're not quite ready yet, you can pause the video, but I'm going to reveal the answer. So pause the video if you're not ready yet to see. So when I'm looking at this excerpt, and again, I've color-coded it red for where, blue for what. Again, that first sentence is addressing both of the criteria for us. It's telling us that this data we're talking about is found in figure 3 of the paper. And the first sentence is saying the largest differences between northern and southern populations occurred at 39 degrees C. So when we expose them to different levels of temperatures, 39 degrees C, we see the biggest differences between the regions at that temperature. So that's one of the main takeaways from the data. And then the second sentence gives us some more of that what information. It's telling us specifically what the numbers of survival are at that temperature for different northern versus southern populations. So now we know, okay, the data that's being referenced here in the results section is found in figure 3. If we pull up that figure 3, we can see now, okay, they're talking about this 39 degrees C here, and if we look overall, the spread is the greatest at this temperature, with the southern populations in the black dots here at the top, northern populations in the white dots here at the bottom. So we're seeing in visual form the results that are being described here, how we have the largest difference between northern and southern populations in terms of their percent survival at 39 degrees C. Another question that several of you asked was how to make your writing more concise and cohesive, how to make it flow better. First of all, I think this is something that just comes with practice. The more you do it, the easier it gets. So this is an example that I pulled from the lecture module where I gave you the weight versus MPG scatter plot that we created back in week 5, and then I asked you to write a figure caption for it. So I have a figure caption here listed that has all the information it needs, but it maybe could be made more concise. So what I'll let you do, I'll give you some time to look at what's written here and think about how you might be able to condense that to make it more concise and more to the point, which is scientific writing is different. We're supposed to be very concise and not wordy, which is different than other types of writing. So I know it's different and can be challenging, but take a look here and see what you might cut to make it more concise. I'll give you some time to think about that. Okay, if you're not ready yet, you can pause the video. I'm going to move on. So how would you make this more concise? We already did that. Okay, so here in red, I have indicated everything that I think could be cut to make this more concise. So these are extra words that aren't bad per se, but they're not needed. So what I have here, the data contained 31 data points. One way we can say that is saying n equals 31. That's a really concise way to give what our sample size is. I also highlighted this sentence here that says we did a linear regression to analyze the relationship between MPG and weight. That's true, but if we look down here, if we're giving an r squared and a p-value, that's already indicating that we did a linear regression, and also because we know these are two continuous variables, we can assume that a linear regression had to be done. We know it couldn't be a t-test, it couldn't be an ANOVA. So that sentence actually isn't necessary here. We can cut that as well. So when we cut all of those parts in red, what we end up with is here on the bottom. So figure 1, miles per gallon plotted against weight of cars. Data were obtained from the MT cars dataset in R, n equals 31, that's our sample size. The correlation between miles per gallon and weight of the car is significant, with an r squared value and a p value listed. So we took what we had here, all of the information is the same, the gist of the figure caption is the same, it's just said in a bit more concise way. And again, this will get much easier with the more practice that you have. Another thing to note when we're writing figure captions or interpreting linear regressions versus ANOVAs, one thing to note for a linear regression is what we're doing is trying to see if there's a significant relationship between these two continuous variables. So we talk about a linear regression and an ANOVA slightly differently if the result of that test is significant. So with the linear regression, we are trying to determine if variation in continuous variable explains variation in the other continuous variable. And when you're reporting statistical values for linear regression, you want to give the R-squared value and the p-value. In contrast, when you are talking about an ANOVA, so this is a bar graph we made from the fish egg data set, for instance. When you're talking about an ANOVA, what you're testing for is whether there's a significant difference between these different categorical variables you're comparing. So with an ANOVA, we're trying to see if the continuous dependent variable, the number of fish eggs, differs across these categorical variables, which here would be the season. And when we're reporting the statistical results of an ANOVA, we give the F value, the F critical value, as well as the P value. So one of you asked about how do we interpret or talk about these tests differently? This is one example. Another question, we're just about wrapping up here. Another question is how to report p-values. So are you supposed to give the exact p-value? Are you supposed to just say it's less than 0.05? So here's another example that I pulled from one of my papers. Again, that paper looking at survival differences of snails from different regions when they're exposed to different temperatures. And people do this differently, but one of the rules that I've followed in the past is if your p-value is greater than 0.001, I give the exact p-value. If it is less than 0.001, I just say less than 0.001. Again, people do this differently, so it never hurts to give the exact p-value. If you're ever unsure, it's always good just to give what the exact p-value is. But this is one of the rules that I have followed in the past, is reporting the exact p-value rounded to 1 or 2 decimal places until it reaches 0.001, and if it's lower than that, then I just say it's less than 0.001. Another example, so that's if you're reporting it in the results narrative. When you're indicating p-values and significance on a figure, often you're doing that, it's my dog, don't know if you can hear him groaning. When you're doing it on a figure, you often indicate significance with asterisks. And often the way this is done is different numbers of asterisks. It's a hard word to say asterisks 5 times fast. It indicates different levels of significance. So here on this graph, if we have 2 asterisks, we know that p-value is less than 0.01. If we have 3 asterisks, we know it's less than 0.001. So when you're writing about it, it never hurts to give the exact p-value, but just so you know, if you see this in papers, or if you want to use it in your figures, the asterisk and the different number of asterisks indicates the level of significance. Usually 1 asterisk indicates the p-value is less than 0.05. Last point here, one of you asked about, just for curiosity's sake, why some figures are in black and white versus color. So you'll notice this figure from my paper here is in black and white. Usually figures are in black and white in papers because you have to pay more to have them published and printed in color. So this I have here, anytime I give a talk about this data, I have a color version of a figure that I use, but when I had to publish it in a peer-reviewed journal, we made a black and white version because we didn't have the money to pay for a color version. So that's why there's that. All right. That is it. So hopefully that clarified some things for you. And of course, if you have other questions, let me know.